In the hidden valley of the Tunguska River, something strange happened that has never been observed. The day of 30th June 1908 started cloudless and sunny. At 8 o'clock in the morning, a farmer was sitting on the steps of his house when there was a huge explosion in the sky. He later told scientists that the fireball was so bright that it even made the light of the sun appear dark and felt so warm. When scientists later investigated, they realized that the explosion had happened nearly 60 kilometers away from the farmer. Seismic waves were observed around the globe, and pressure waves in the atmosphere spread throughout Russia and Europe. The blast was visible 700 kilometers away and threw smoke and dust into stratosphere. It took 2 months to recover from the damage. Life had been totally destroyed and remained so far over a 25 years of period. Researchers excavated to depths of over 30 meters, but no signs of meteorite material or any physical trace of the explosion have ever been found. There were records that showed the Earth's magnetic field was disturbed, and seismometers had recorded the strength of the apparent earthquake. Reports of the brightness of the flash and its duration were used to predict the reason for explosion. Scientists deduced that almost a million billion joules of energy had been released in few seconds, which is 1 million times the energy released by a lightning storm. According to the data, the reason for this destruction is a thing that is only as small as a meteor that destroyed everything, including the nuclei of atoms. The only thing known to man that can cause such a destruction is antimatter. Antimatter is defined as matter which is composed of antiparticles. We know particles which forms all the things. Antiparticles are just like enemies to particles. Particles and antiparticles have everything in common except charge. So, electron's antiparticle is anti-electron, also called positron. Proton's antiparticle is antiproton and hydrogen's antiparticle is antihydrogen. But a neutron has no charge. It's neutral. But neutron's antiparticle is antineutron. This is because an antiparticle and a particle have differences in their quantum numbers, also which describes their quantum properties. Particles and antiparticles are enemies. So, when we keep them together, they both disappear in a very short time. They kill each other by releasing pure energy in the form of gamma rays, the high energy photons, neutrons, and sometimes less massive antiparticles. This process of destroying each other is called annihilation. Most of the energy from the annihilation of matter and antimatter released in the form of ionizing radiation, which contains high energy photons, which is powerful enough to kick electrons from atoms. The entire mass of particles and antiparticles is completely converted to energy, which holds the Einstein's mass-energy relationship. The energy from matter-antimatter collisions is so huge that it is about 10 times greater than chemical energies, and 3 times greater than the energy from nuclear fission and 2 times greater than nuclear fusion. According to Einstein's mass-energy relationship, the reaction of 1 kg antimatter with 1 kg normal matter would produce 180 petajoules of energy. This energy is equivalent to 43 megatons of TNT and slightly less than the energy from 27,000 kg Tsar bomba, the largest thermonuclear weapon ever used. So far, we have observed antimatter in cosmic rays. In January 2011, American Astronomical Society discovered that antimatter originating above thunderstorm clouds. Due to the strong electric fields in thunderstorm clouds, electrons, accelerate and creates gamma ray flashes that produce positrons. Artificially, small amounts of antiparticles are generated daily at particle accelerators, but the total production is only a few nanograms. The most complex antiparticles ever created is the nuclei of antihelium. It is so difficult to store antimatter because whenever it touches normal matter, explosion. So, antimatter in the form of charged particles is stored by using electric and magnetic fields in a device called a penning trap. In 2011, CERN scientists were able to preserve antihydrogen for approximately 17 minutes. That's why antimatter is the costliest material to make. It would cost $25 billion per gram of positrons and $62.5 trillion per gram of antihydrogen. Matter-antimatter reactions are used for medical imaging such as positron emission tomography. If you have ever had a PET scan, you will have ingested antimatter. Perfectly stored antimatter could be used as a fuel for interplanetary or interstellar travel. Antimatter fuel is two types. We can use it to trigger nuclear explosion, which is called antimatter catalyzed nuclear pulse propulsion, and the way is to build antimatter rockets which can reach nearer to light speed. But it's a hard thing to use antimatter as fuel because of annihilation. Most of the antimatter reactions result in gamma radiation, so it's difficult to produce thrust. Antimatter has been considered as a trigger mechanism for nuclear weapons. The US Air Force funded studies of the physics of antimatter in the Cold War and began considering its possible use in weapons, not just as a trigger but as the explosive itself. Positron bombs won't release radioactive waste, so it can't affect the lives of further generations like that happened to Hiroshima and Nagasaki. A major obstacle is the difficulty of producing antimatter in large enough quantities, and our theories are not capable enough to harvest antimatter to power up rockets. For example, a positron, the antiparticle of the electron, and an antiproton, the antiparticle of the proton, can form an antihydrogen atom. Like that, anti-hair, anti-chair, anti-you, anti-me, anti-ant. Some scientists thought that antiparticles can have anti-gravity abilities. But the equivalence principle states that gravity affects antimatter and matter equally. In the beginning, during the Big Bang, there were equal chances for both matter and antimatter to burn in equal amounts. If that's the case, matter and antimatter annihilate each other with a powerful explosion, and our universe would be energy, dark matter and dark energy, and nothing else. But things didn't happen in that way. Our universe consists matter. That's why we are here made up of atoms created some billions of years ago. There are strong evidences that the majority of the known universe is made up of matter, not antimatter. So matter dominated antimatter. This is one of the biggest mysteries in physics. No one knows why matter is abundant and antimatter is rare. If we can solve this mystery, it can get us closer to the mystery of the universe. Some believe in another conception that Big Bang created equal amounts of matter and antimatter, and somehow they didn't annihilate each other. This created two different universes containing matter and antimatter. These universes are similar except the conception that in the antimatter universe, time runs backward. But these conceptions have no proofs. Antimatter again reveals the truth that the things we don't know are a lot.